Dear students and my dear friends, today in this session of Production and Industrial Engineering, we are going to discuss some topics from the subject of Industrial Metrology and Statistical Quality Control. So, as this subject is important for production and industrial engineering students, the topic today which we are going to discuss are inspection, standards of measurements, interchangeability, accuracy and precision, international, national, line and wavelength standards. So, let us start with the first topic from this subject. Here is the rationale of this subject, that is why this subject is important for production and industrial engineering students. So, diploma holders studying this course are responsible for measure and inspection for ensuring quality of the product on the shop floor. So, for this purpose, knowledge and skill about standards of measurements, limits, fits and tolerances, types of inspection and various measuring instruments and SQC, which is statistical quality control, is necessary. Hence, he or she must be aware of quality system, hence this subject. So, first topic is inspection. So, inspection is most generally an organized examination or formal evaluation exercise. So, in engineering activities, inspection involves the measurements, test and gauges applied to certain characteristics in regard to an object or activity. The results are usually compared to specified requirements and standards for determining whether the item or activity is in line with these targets. Inspections are usually non-destructive in nature. So, a surprise inspection tends to have different results than an announced inspection. So, leaders wanting to know how others in their organization perform can drop in without warning to see directly what happens if an inspection is made know in advance. So, it can give people a chance to cover up or to fix mistakes. So, this could lead to distorted and inaccurate findings. So, a surprise inspection therefore gives inspectors a better picture of the typical state of the inspected objects or process than an announced inspection. So, a surprise inspection is always better than an announced inspection. So, it is enhanced external confidence in the inspection process. Need of inspection. Number one is to ensure that part, materials or a component conform to the established standards. Second, to meet the interchangeability of manufacture. Third, to maintain customer relation by ensuring that no faulty product reaches the customer. Fourth is to provide the means of finding out shortcomings in manufacture. The results of inspection are not only recorded but forwarded to the manufacturing department for taking necessary steps so as to produce acceptable parts and reduce the scrap during the production process. So, fifth is it also helps to purchase good quality of raw materials, tools, equipments which governs the quality of the finished products. So it is also help to coordinate the functions of quality control, production, purchasing, and other departments of the organization. Seventh is to take decision on the defective parts, that is to judge the possibility of making some of these parts acceptable after minor repairs during all this production process. Units of measurement. A units of measurement is a definite magnitude of a physical quantity. So here stress is given upon the physical quantity, defined and adopted by convention and or by law, that is used as an standard for measurement of the same physical quantity. Any other value of the physical quantity can be expressed as a simple multiple of the units of measurement. For example, length here is a physical quantity. So length is a physical quantity. The meter is a unit of length that represent a definite predetermined length. Here the meter is also used as a unit of length that represents a definite predetermined length. So when we say 10 meters or say 10 m, we actually means 10 times the definite predetermined length called meter. The definition, agreement, and practical use of unit of measurement have played a critical role in human endeavor from early ages up to this day. So different systems of unit used to be very common. Now there is a global standards, the International System of Unit, which is shortly known as SI, the modern form of the old metric system. Metric system is the MKS system, which is lastly known as MKS system. So in physics and metrology, units are standards for measurements of physical quantities that need clear definitions to be useful. Reproducibility of experimental results is certain to the scientific methods. A standard system of unit facilitates this. The scientific system of units are a refinement of the concept of weights and measures developed along for commercial purpose. Science, medicine, and engineering often use larger and smaller units of measurement than those used in everyday life and indicate them more precisely. The judicious selection of the units of measurement can aid researches in problem solving. International system of units. First of all, definitions. A quantity is, in the general sense, is a property ascribed to phenomena, bodies, or substance that can be quantified for or assigned to a particular phenomena, body, or substance. For examples, mass and electric charge. A quantity in the particular sense is a quantifiable or assignable property ascribed to a particular phenomena, body, or the substance. Examples are the mass of the moon and the electric charge of the proton. So, a physical quantity is a quantity that can be used in the mathematical equations of science and technology. A unit is a particular physical quantity defined and adopted by conversion with which other particular quantities of the same kind are compared to express their values. So, all physical quantities can be expressed in terms of 7 base units. First of all, the base quantities, then name of that quantities, and then the symbol used for that quantities. First base quantity is the length, name is meter, and symbol used is small m. Base quantity is mass, name is kilogram, and the symbol used for kilogram is kg. Similarly, base quantity is time, name is second, and symbol used for second is small s. Electric current, name is ampere, and symbol used is capital A. Similarly, base quantity is temperature, name used is Kelvin, and symbol used for Kelvin is capital K. Amount of substance, this is base quantity, name used is mole, and the symbol used for mole is MOL. Similarly, the base quantity for luminous intensity, the name used for luminous intensity is Candela, and the symbol used for Candela is CD. Derived units. Other quantities called derived quantities are defined in terms of the 7 base quantities via a system of quantity equations. The SI derived units for these derived quantities are obtained from these equations, and the 7 SI base units. Examples of such SI derived units are given, where it should be noted that symbol 1 for the quantities of dimensions 1 such as mass fraction is generally omitted. Derived quantity is area, and the name used is square meters, and the expression in terms of SI units, that is International System of Units, is m square. Similarly, derived quantity is volume, the name is cubic meter, and the expression used is m cube. Similarly, derived quantity speed, velocity, the name used is meter per second, and the expression used is m per s. Similarly, acceleration is derived quantity, the name is meter per second squared, and the expression used is m oblique s square. Similarly, derived quantity for mass density is kilogram per cubic meter, and the expression in terms of SI unit used is kg per meter cube. Similarly, for derived quantity force, the name used is Newton or capital N, and the expression in terms of SI unit are m kg per second square. So, similarly, for pressure, name used is Pascal, and expression is m raised to power minus 1 kg per s square. Similarly, for energy work, joules, J or Newton meter, expression used is m square kg per second square. Similarly, for electric potential, name used is volt, that is V, and expression used is m square kg per s cube and A. Standards of measurement. The law of physics are expressed as mathematical relationship among physical quantities. Most of these quantities are derived quantities, or they can be expressed as combination of some basic quantities. So there are mainly three quantities in physics or mechanics. These are: number 1 is length, 2 is mass, and 3 is time. Interchangeability. An interchangeable part is one which can be substituted for similar part manufactured to the same drawing. In either times, production used to be confined to small number of units, and the same operator could adjust the matching components to obtain desired fit. So, with time, the concept of manufacturing techniques kept on changing, and today the same operator is no more responsible for manufacture and assembly too. So, with economic oriented approach, mass production techniques were inevitable that lead to breaking up of a complete process into several smaller activities, and this lead to specializations. As a result, various matching components will come from several shops. So, ever a small component would undergo production on several mechanics. Under such conditions, it become absolutely essential to have strict control over the dimensions of portions which have to match with other parts to get the desired production rate. So, any one component selected at random should assemble correctly with any other matching components that too selected at random. So, when a system of this kind is ensured, it is known as interchangeable system. So, interchangeability ensures increased output with reduced production cost. So, in this system, it is sure that the production cost is less and the output means production is increased. Accuracy and precision. The accuracy is how close a measured value is to the actual or true value. So, precision is how close the measured values are to each other. So, in the field of science, engineering, industry and statistics, the accuracy of a measurement system is the degree of closeness of measurements of a quantity to that quantity's actual or true value. The precision of a measurement system, also called reproducibility or repeatability, is the degree to which repeated measurements under unchanged conditions show the same results. So, although the two words reproducibility and repeatability can be synonymous and colloquial use. They are deliberately constructed in the context of scientific methods. So, here in this diagram we can see that in this horizontal axis this is value, and in vertical this is a probability density, this is the reference value, and this area shows the accuracy of the system, and this curve repeated shows the precision of this system. So, accuracy indicates proximity of measurement results to the true value, precision to the repeatability or reproducibility of the measurement. So, this is the basic difference between the accuracy of a system and the precision value of a system. A measurement system can be accurate but not precise, precise but not accurate, neither or both. So, for example, if an experimental contains a systematic error, then increasing the sample size generally increases precision but does not improve accuracy. So, the end result would be a consistent yet inaccurate string of results from the flawed experiment. So, eliminating the systematic error improves accuracy but does not change precision. A measurement system is designated valid if it is both accurate and precise. So, here we can say in this accuracy versus precision. So, this is a diagram of a dot board, and these pins are striking this dot board. If these pins are striking in this way as shown in this diagram, we can say this is good accuracy and poor precision. But if these needles strike in that way on this dot board, we can say that this is good accuracy, good precision and poor accuracy. So, if these needles hit this dot board in the center way as shown in this figure, this is the case of good accuracy and good precision. So, always good accuracy and good precision system is desirable. So, this is the comparison chart about accuracy and precision, about a term used in measuring something. Similarly, in case of precision, a term used in measuring something. So, if we discuss the definition of accuracy, it is accuracy of an experiment object value is a measure of how closely the experimental results agree with a true or accepted value. Similarly, the definition in case of precision is precision of an experiment object value is a measure of the reliability of the experiment or how reproducible the experiment is. Similarly, in case of accuracy, measurements is single, and in case of precision, a number of measurements are needed. And if we talk about the quality of the accuracy, it does not speak of quality, and in case of precision, it speaks of quality of the product. Similarly, uses in case of accuracy, physics, engineering and statistics, etc. So, in case of precision, we can use in physics, engineering, statistics, etc. International standard. International standards are standards developed by international standards organizations. International standards are available for consideration and use worldwide. The most prominent organization in the International Organization for Standardization. International standards may be used either by direct application or by a process of modifying an international standards to suit local conditions. The adoption of international standards result in the certain of equivalent national standards that are substantially the same as international standards in technical content, but may have number one is editorial differences as to appearance, use of symbols and measurement units, substitution of a point for a comma as the decimal marker, and second is differences resulting from conflicts in governmental regulations or industry specific requirements caused by fundamental climatic, geographical, technological or infrastructural factors, or the stringency of safety requirements that a given standard authority considers appropriate. International standards are one way of overcoming technical barriers in international commerce caused by difference among technical regulations and standards developed independently and separately by each nation. So, national standards organization or company. Technical barriers arise when different groups come together, each with a large use base, doing some well established things that between them is mutually incompatible. So, establishing international standards is one way of preventing or overcoming this problem. Definitions of International Organization for Standardization, that is ISO. The world's largest developer and publisher of international standards. The ISO is a network of National Standards Institute of 163 countries coordinating by a central secretariat in Geneva. So, for example, in a currency context, ISO 4217 is the international standard established by the ISO that specifies the structure for the three-letter codes used to describe the many currencies used around the world. So, this is the duty of the ISO, which is International Organization for Standardized, to control all these activities internationally. Standards organizations. So, there are many standards organizations that establish the implement standards. Some of most prominent are American Petroleum Institute, it is known as API, American Society for Testing and Materials, known as ASTM. Similarly, British Standards Institute, BSI, European Computers Manufacturers Association, ECMA, Institute of Electrical and Electronics Engineers, IEEE, International Electrotechnical